Hey y'all, CB here at NBS Welding, coming at you from the shop with another project. This is going to be a good one. Buddy of mine got a hold of me recently wanting to know if I'd be willing to do some work on his dad's tractor. His dad had an issue with his tractor, and I've got the tractor in the shop right now. Let's take a look. What we got here is Mahindra little tractor loader backhoe. Very similar in size to my Kubota, a little bit older. And the issue that we got involves the bracketry for the loader. Obviously, there's some parts here being held on by ratchet straps that are actually supposed to be held on with bolts. But let me tell you, we done a little CSI on the situation, and here's what we have surmised has happened. If you look closely at right here's your loader bracket. And he didn't bring the loader, and I don't need the loader. That would just be in the way if it was on there right now. But this is a bracket, the bracketry on the tractor that's going to hold the loader arms to the bucket. Now, if we get in here and look on this side where there's no damage, right there we see that there's bolts missing. And that's the beginning of what we discovered on our crime scene investigation here. So what we're believing happened to the other side is bolts came loose in the bracketry, and some bolts came out, got lost. He's operating the machine. He's totally unaware that had taken place. So he continues to operate the machine, and bolts continue to come loose and come out until the point that there's no longer enough bolts in the machine to hold it together, which at some point caused the rear section where it's bolted on, actually I believe to the transmission housing of the machine, it came loose. And actually it looks like the last bolt broke off. I can show you that. So we look in here. This is part of the transmission housing, I believe. Yeah, I think it's part of the transmission housing where the loader bracketry bolts on there. And what we see when we look at that is there's a bolt broke off, stuck inside the machine right here. And then when we look at the back right there, there's a portion where there was a bolt where it snapped the cast right off. So right there was the beginning of the failure here. We got something there that would have had 1, 2, 3, 4, 5, 6 bolts in it. And bolts came out of that probably to the point that there was only 2 bolts left. And 2 bolts wasn't enough to hold it. So it broke loose. When that broke loose, there's an issue created immediately because the front of the loader arm bracket, which would be this right here, is now the only part holding it. Where this plate's supposed to be bolted on here, and this is supposed to be bolted on right here. Now, there's nothing being held together between here and here. And the only thing you have left holding it is the front bracket where this is bolted on right there. And what we see when we see what happened, it broke that. Now all the bolts are still in there. This one right here looks like there might be an issue with it. It's backed way out. But you see there's a piece of steel right there, and there's a piece of steel in the front. And those are pieces of steel that are were supposed to be connected to this. So you can see we got quite a boggle here. To get this loader back on here, this is going to take some ninja skills. There's going to be some Jedi mastery that has to take place here. Where there is a bolt broken off in the machine, that bolt needs to be extracted. Either extracted, drilled out, helicoil put in, retapped, who knows? Who knows what we're going to do there, but we got to fix it. Where the cast transmission housing is broke completely off, the most likely proper fix scenario for that would be to actually weld onto that housing, which right now I don't know if that's cast iron or cast steel, but I have to find out to know how to weld it, and we'll find that out. But on a hunk that's completely broken off and lost, you're probably going to have to weld that up solid, re-drill it and re-tap it so that it'll accept a bolt to hold the bracketry back on. And then here in the front, where we have basically 3 pieces of steel that used to be one and need to be one again, that bracketry needs to be lined back up the way it needs to be, tacked together, and full penetration welded so that it's just as strong as it was before. So there's a lot that needs to happen here. This involves disassembling a lot of this side of the tractor so we can get in there and work. I don't know what hydraulics we may or may have to disassemble. I'm just going to have to tear into it and see what's up. It's a situation where you need a welder, you need a machinist, you need a mechanic, you need a ninja, you need a Jedi master, somebody that's just going to go in here and do whatever needs done. Because honestly, on the age of this tractor, if you were to take this to the local dealership that charges $150 for labor and they just replaced all the broken parts, this tractor's probably totaled. It would probably cost as much as the tractor's worth. But yet, it's a great thing for me to fix. I'm going to do Dad some doozing. The guy brought it here. He's a good old boy. It'll make my heart happy to fix it for this guy, because as soon as I met the guy, I liked the guy. He's a good old boy. It's obvious that he's one of them guys that could probably get more done with a pocket knife than some people could do with a whole toolbox full of stuff. But he can't do this. He needed help. And he said, man, I know you got a reputation around here. I've talked to people about you. They said, if anybody can fix it, you can fix it. And the way I feel about it, I won't be outdone. So I'll either fix this or I'm going to keep on working on it until it's so messed up that nobody can fix it. We're going to make something happen here. So, and hopefully what I can do, my rate is extremely low, especially on stuff like this. Hopefully what we can do is get this fixed at a reasonable cost to the guy and, get him back to work. The old boy, you get a special relationship with a tractor like this. And I can tell that guy, this is one of the guys that he could probably do more with this little tractor than some people could do with a bulldozer, just because, like I say, you get a relationship with a machine, and I think it means a lot to him. So it's going to mean a lot to me to fix it, and we're going to get on it and see what we can do here. Getting into this tractor. Done some mechanicking. We've got into where we can, got things apart where we can see what's going on. Our mounting areas, the main mounting area where we had the big failure is right here. These 6 bolt holes. 1, 2, 3, 4, 5, 6. Where we've had the steel break, this bracket right here. And this one piece of steel right here, one piece of steel right here, and this third piece of steel on the bracket used to be one piece of steel. Now, my first order of business here was to see how much trouble we're in with bolt holes. Obviously, this has got to be bolted back on there. If we can't bolt it back on there, there's no sense even thinking about welding the part that needs welded. So the first thing with the bolt holes is, obviously we have one bolt that's broken off in the machine. We have another bolt hole where there's enough cast broken away and lost that it's not going to hold threads. There's 3 other holes there that are threaded, and I've run taps in all of those, and they're okay. This one, this one, this one, and this one is fine. This one right here's got a bolt broken off in the machine, in the transmission housing. This one's got so much cast missing that it's not going to hold a bolt. So this is the first area where I'm going to do any work. And the first thing that I want to try to do is extract this broken bolt. Now, a common way to try to, there's different ways to do this. You could drill a hole in that bolt and extract it with an easy out. That's probably the slowest way. And it doesn't always work, because if the bolt is stuck in there, your easy out is always smaller than the diameter of the bolt. So if the bolt's really stuck in there, even if your easy out gets a good grip on the bolt, it'll snap off sometimes before it extracts the bolt. Generally, an easy out will work on a bolt that's not stuck. If the bolt's stuck, your best bet to extract it is to weld on it somehow and get a hold of the bolt by welding, and weld on the bolt as much as you can grab, meaning that's the difference between welding on the bolt and using an easy out. If you drill a hole through the center of that bolt and you try to extract it with an easy out, obviously the easy out is going to be a smaller piece of steel than the bolt. So if the bolt's really stuck, that might not work. If you're welding onto the bolt, and that bolt right there is 12 millimeter in diameter, then I can weld almost 12 millimeter in diameter. So I can get a hold of the most that you can get a hold of, I can get a hold of by welding. What most guys will take off immediately trying to do is they'll stick a washer up there, or not a washer, but a nut. They'll stick a nut up there and they'll try to weld the bolt to the nut. A lot of times that works, and if it's not stuck very bad, that'll work. There's 2 things that work in your favor. One is you're welding the nut to the bolt. The other thing that works in your favor is you're heating it up. And every time you heat it up and it expands and contracts, that could loosen it up. Now, we don't want the bolt to be hot when we extract it. Hot steel is expanded and it's bigger. We would rather the bolt to be cold when we extract it, because cold steel shrinks and it's smaller. If anything, you would want the housing to be hotter and the bolt to be colder, which obviously that's not always the easiest thing to do, but measures can be taken if needed to make that happen. Now, what I'm going to do, knowing how important it is that I extract this bolt, is I'm going to focus on this just one thing at a time. And the first thing I'm going to focus on is getting weld onto that bolt. What I mean by that is I'm not going to try and hold a nut up there. I'm not going to try and hold a washer up there. I'm just going to weld onto that bolt. And I'm going to try to build up weld onto that bolt without welding it to the housing, which is one of the tricks that you need to do. You need to weld on the bolt, build up metal on the bolt, but don't weld the bolt to the housing, which would be obviously a big mistake. Now we can see that this surface of this bolt is a little bit lower than the housing. It's just, you know, 1/8 of an inch or so lower. So that's one of the reasons that it would be beneficial for me, while there's no nut or washer or anything in the way, to just weld right onto that bolt and get weld metal built up on that bolt before I put anything up there to try to weld it to grab it. So step number 1 is going to be welding on the bolt without welding to the housing. Step number 2, I will probably put something up there like a washer and weld my weld to that washer. Once I've welded my weld to that washer, I'll take something like a nut that I can get a hold of and weld that to the weld and to the washer. And then we'll try to extract it. So that's going to be the first part of this repair, and I'll get a welding shirt on and we'll get to it. All right, I'm about ready to start welding on this bolt. There's a couple things I'll show you about the way I've got this set up. You notice right here, I've put a bolt in the transmission housing, and I've connected my ground clamp to that bolt. That bolt is only a few inches from the bolt that I need to weld on. A lot of times, everywhere you go, whenever you're going to weld on a machine, people will say, disconnect the battery so you don't burn up the computer. I don't see how disconnecting the battery is going to ensure that there's no way that electrical juice from the welding can go across the computer. The computer's connected to both positive and negative. If you ground in one place and you arc on some other place in the machine and that computer's in between there and something's shorted out where it's allowed to, that welding current to get to it, whether the battery's connected or not is irrelevant. The only thing I believe that disconnecting the battery does is it makes sure that the machine's not going to run again until you take the time to reconnect the battery. Maybe it does more than that, I don't know. But I'll tell you this, when you connect a ground clamp to weld on something, connect that ground clamp as close as possible to where you're going to weld, and don't touch anything else with your welder. That juice is not going to go anywhere else. If you ground right here and you weld 2 inches away and you don't ever touch your welding rod to anything else, then that juice is not going to go anywhere else. Now, whether the battery's connected or not, if I've got the ground clamp connected to that bolt on the transmission housing and I go up there and weld on the engine somewhere, we don't know where that juice might go through. There could be wires shorted out in this thing somewhere that would allow that juice to go to the computer or even blow up the battery. I don't know. But I'm not going to worry about it because I'm going to connect my ground clamp a matter of inches away from where I'm going to weld on exactly the same piece of steel on a clean area where I know I'm going to get a good ground, and I'm not going to weld on nothing else. So that's it for that. Next thing's going to be, what am I going to weld with? I'm going to do this with a 3/32 inch 5P plus pipe rod. I like a pipe rod for this because I don't want a whole bunch of slag. Minimum amount of slag, and I want to be able to see what I'm doing so that I can make sure that I am only welding on the bolt. So let's put a little weld on this bolt and warm up on it and see what happens. Now, after dabbing weld on that a few times, now I've got weld that's sticking out. Sticking out a little farther than the surface of the housing. So at that point, I think it'd be more appropriate now to put a washer up here and try to weld that weld to that washer without welding it to the housing. And you can see how you're going to have a little better luck grabbing a hold of that washer to the weld. Because if you put a nut up here first, you got to get way back in there. And I just want to do this one step at a time. So I say, let's get that weld welded to that washer, and then we'll worry about welding a nut on. So we got our washer welded onto the weld, and the weld that's welded onto the bolt, and hopefully none of it's welded to the housing. The next thing would be putting something on there that we can grab a hold of to extract it with, which was obviously a decent choice, would be a nut. So the major bolt issue number one right there is no longer an issue. I was able to get that bolt extracted, which is great. And the threads that are inside of there that remain are not damaged, which is even better. That's good on top of good. So the next disaster as far as bolting this back on that we got to worry about is where this huge hunk of cast is broke out of this bolt hole and missing. Now putting a tap in there and trying to tap threads and a helicoil or anything like that, none of that would be any use whatsoever in this situation where there's a hunk of the housing that's just gone. What needs to happen here, I believe, is that bolt hole and that area that's missing, the hunk of housing that's gone, is going to have to be welded up solid. Then a whole new hole drilled out and threaded. That's what I propose attempting to do here. And the trickiest thing about doing that on this particular thing is this transmission housing is not mild steel. It's cast. So with any cast, the first thing is, what is it? Because if it's cast iron, that's a completely different animal than if it's cast steel. Now, the way I go about testing to find out if something is cast iron or cast steel is to try to cut it with a torch. If I can cut it with an oxyacetylene torch, then I can weld on it with a mild steel electrode. Preferably a 7018 low hydrogen welding rod. Although a MIG would probably work, as long as it's cast steel. And if it's cast steel, a torch will cut it. If it's cast iron, a torch won't cut it. When you try to heat it up and blow your oxygen and cut, it just won't cut. It'll like sparkle and laugh at you. And, maybe melt at the corner just slightly, but it won't cut. I know a lot of guys do a spark test with a grinder. I believe in everybody's got their own ways. I'm a believer in, if I can cut it with a torch, I can weld it with a low hydrogen. If I can't cut it with a torch, I consider it to be cast iron. And if it's cast iron and I'm going to arc weld it, I'd have to arc weld it with a nickel rod. So the next thing is going to be getting out the oxyacetylene torch and finding out whether we've got cast steel or cast iron to work with here. So trying to cut on that with an oxyacetylene torch shows it to be what I would call cast iron. When I try to cut it, you can't just start blowing oxygen on the hot metal and blow it away like you could if it was cast steel. It does sort of cut, but for any practical welding purposes, I would call this cast iron. And it needs to be, if you're going to arc weld it, it needs to be welded with a nickel rod. That creates a whole new problem for me because the nickel is very hard to machine. Drilling a hole in solid nickel, if I was to weld that up, just drilling the hole would be a job in itself, let alone tapping threads in it. The nickel is, I don't think it's an option I ran around quite a bit yesterday evening in town, buying metric bolts because I had measured and found out what I needed to put this back together. And I got some extra taps and things, and really high quality, machinist quality drilling and tapping equipment is not going to be available, readily around here. I could order stuff like that, but you're talking about spending major bucks and waiting to get it. So as far as working with what I got, I'm wondering about building this up with some bronze, which I would not apply by arc welding. I would apply bronze by way of oxyacetylene flame welding. I would rather arc weld it quick, with the nickel rod. I've welded a lot of cast iron with nickel rod, and it's strong. But I just don't think I can drill and tap the nickel. And I don't even know if getting the right size cobalt drill with the right tap in a really high quality 12 millimeter by 1.75 metric tap. I don't know if that's in the cards for something like this. I've got to think about what I'm going to do here. That's what it looks like after I went at it with oxyacetylene. Regardless of what I end up doing here, I'm going to go at that with a grinder and dress it up, get it ready to do something to it. So taking the grinder and preparing that to weld on it with something, right there's where I'm going to stop grinding. That's what she looks like. While I was grinding on that, I was, thinking about what I should do here. I would really, really like that to be mild steel. I would really like to be able to weld on that with a 7018 mild steel welding rod, weld it up, and be able to drill and tap that material. That material would hold threads good. It's got great elasticity. It's very strong. Will it stick to that cast? The other thing I mentioned was using the oxyacetylene to build that up with a bronze rod. That would be an option. What I'm thinking about the bronze is that if I build that up with bronze rod and drill and tap it, it's going to be soft. A lot softer than, as far as holding threads, bronze is not ideal. Nah, it's not aluminum, but it's not cast iron either. So I don't know that bronze is the right thing to do. But here's what I'm thinking right now. I wouldn't hurt anything if I took a 7018 and started welding on that just to see how I feel about it. And if it won't accept it, it would probably crack right away and show me that it's just not going to mix. But then again, a 7018 sometimes will really surprise you what it'll do on dissimilar materials. This may be steel enough that a 7018 would weld it all right for this purpose. I'm going to try it. And I don't think I got nothing to lose. If I put some weld on there and I got to grind it all back off, who cares? I'm not going to sit here with my thumb up my butt. I'm going to weld on it, and I'm going to weld on it with a 3/32 7018 and just see how it accepts it, see how it acts. Everything I can tell up until now, welding on that with a low hydrogen was probably the right thing to do. It seemed to mix with that cast just fine. It's still hot. It could crack when it cools, but I don't expect that to happen. I don't expect to see that happen because it welded and it mixed so good. So let's take a look. One of the main things I wanted to make sure that I really tried to put more on there than I needed. And the thing is, I'm going to be obviously grinding that to get it flat and get it down on the same plane as the rest of those bolt holes. But one of the main things is, you wouldn't want to find out later that you needed to put more on it because you'd have to weld on it more later. And one of the things we don't want to do with this cast is heat it up and cool it down a bunch of times. I had to heat it up to get it welded, but you want to get it welded and be done with it. You don't want it heated up and cooling down and heating up and cooling down and having all that expansion and contraction. Now, if one of the issues that you have when you're welding dissimilar metals, this is what I would call dissimilar metal welding, because this housing is not mild steel and I'm welding on it with a mild steel electrode. But one of the things that you have is that when this cools down, that mild steel, when it cools down and shrinks, may cool down and shrink at a different rate, at a different speed as that cast that the housing is made out of. And that is something that causes things to crack apart. I've seen cases where somebody welded a cutting edge on a loader bucket, and then everybody's sitting around eating lunch and you hear something that cracks, sounds like a 22 shot just went off, and you go over there and there's a 4-foot crack between the cutting edge and the loader bucket where the guy just welded, and that means that cutting edge shrunk at a different speed. When it cooled down, it shrunk at a different rate of speed than the base metal did, and it cracked. Like I said, I don't expect to see that happen here. And in a lot of cases with welding cast, that's the reason you preheat, because preheating will slow down the speed of the shrinkage when you stop welding. I didn't preheat here, but this is a little bit different because of the amount of welding that I put on it. I think since I had to put so many passes here, preheating wouldn't have done anything. This thing's hotter than the hubs of hell just from the amount of weld that I put on it, and it mixed good. I think we're going to be in good shape. Obviously, I'm not going to try and grind it or touch it or do anything to it until it cools down. When it cools down, I'll look for cracks. I'll be listening for cracking, and if we don't have any problems, then we'll move on to grinding this down and getting it down to the same plane as the other bolt holes for this plate to go on. we've been struggling here with drill bits. Had a pack of cheap drill bits. The whole case full of them's like 20 bucks. I was trying to use the cheap drill bits and work my way up, and it was kind of working, but getting up near the size I need to drill, which is 13/32, even when I was only stepping up just a little bit in drill bit size, the bit would go dull. They're really cheap, you know, like a $20 Harbor Freight set. So I just went and bought 3 drill bits, but to get 3 quality drill bits, these are 10 bucks a piece. You know, I just spent over $30.43 on 3 drill bits. But that's what it's going to take. So here we go. Got it tapped out. Got good threads cut in it. And that only took one of them good drill bits. So I might be able to take $20 worth of them drill bits back. I'll hang on to them until we get completely done here, but probably should have just bought a good quality 13/32 drill bit to begin with, because that plowed right through there. But anywho, moving on. All right, seeing as how that issue with the bolts in the transmission housing is pretty much all dealt with now, we're going to turn our attention to the bracket that's broke in the front. Like I said before, what we pretty much got on that front bracket boils down to there's 3 pieces of steel here that used to be 1 piece of steel. You know, this would be the rear piece. I've got it off there. The front piece is still bolted onto the tractor right there, and then there's a piece that goes on the actual loader arm bracket too. So let me show you what we're looking at. This is the plate on the loader arm bracket, and you can tell by the shape of it that it was right there. And then this, you know, bolted on here, that round area right there that's what this is that snapped out. So now that these bolt holes here are dealt with, you know, where that plate bolts on, I can take this whole assembly and I'll swing it over there, and we'll get a few bolts in here where we can line up that front piece and get some stuff tacked. The first part of this that I'm going to want to do is I'm going to go ahead and grind and prep these parts. And this being mild steel, and I can get it really clean, I'll probably just meg all this. So while it's apart in these 3 pieces, I'm going to get it real clean with a grinder. Let's go to work on that. Nice to see that up there where it belongs, but I never would have dreamed I would have that much trouble bolting that on there. If I had welded and drilled all those holes, I would have thought that I really screwed up bad. I only welded and drilled one hole, and that one was the easiest one to deal with. But there was, you know, I had 1, 2, 3, 4, 5. I had 5 bolts in there, and that 6th bolt, which would be that one back there. I couldn't get that bolt in there. I couldn't get it to line up where I could put that in there. I just spent 40 minutes trying to put those 1, 2, 3, 4, 5, 6 bolts in this thing. And I learned something that I probably already knew before and forgot, which was if there's a bolt that's that hard to reach, put it in first. I should have put that bolt in first when I could move the whole assembly more free, and then messed with the other 5 bolts, and I may have been ahead, which I'll know when I have to take apart everything I just put back together, because I have to weld this, and I'm going to have to access both sides to weld it. And we've got it in position to do this. This is a part that's got to get welded together, and it's in position to do that. So what's going to happen here, I'm going to weld what I can on the outside of that. I'm going to disassemble this and then weld the other side, you know, make sure I'm getting a full penetration weld that's, you know, welded good, and then I can put the thing back together. But yeah, we're ready for that part. It's time to start welding. Well, at this stage of the game, I've put some paint on where I've worked. This plate that used to be the 3 broken plates that's all welded back together. I put some paint on it. I put some paint over here on the tractor where we done all the welding and build up. And just took a spray can and done some painting. Did that real early this morning, about 3:30. Had some other things to do and went to the gym and come back, and I'm ready to put this back together. The paint's all dry and ready to go. Couple important points about reassembling this, and parts of it that really need to pay attention to. You probably remember earlier I was saying how whenever I had trouble putting them 6 bolts in there, I messed around for 40 minutes trying to get them 6 bolts in here. Well, at this point, I've got those 6 bolts to put in, plus 5 more in the front, and I would like to blue Loctite all of them. The main issue, we believe the main reason that this whole problem started in the first place was because these bolts loosened up on him when he was running the machine and he didn't know it. That to me tells me that Loctite would be a good idea on these bolts. So I want to Loctite them, and I'm going to use blue Loctite. Red Loctite's permanent. I don't use red Loctite. If I was going to use red Loctite, I wouldn't. I would probably run the bolts in and then tack bars across the heads of the bolts so that they couldn't turn. Rather than glue something in there that was permanent in the threads, I would tack bars across the heads of the bolts to stop them from ever turning. The red Loctite's that's a bridge too far for me. The blue Loctite will definitely glue them threads where you don't have as much concern about something jiggling loose, but it's removable. You'll be able to get it back apart. If you put the red Loctite in a thread, Loctite says that you're either going to need heat or special tools for removal, and I wouldn't want to do that on somebody's machine. So here's the thing about putting this blue Loctite on these bolts and having this many bolts to put in, and the fact that when I done this before, it took me 40 minutes to put it together. For your Loctite to work correctly, you really only got 10 minutes. You know, you want to get all the bolts tight when the Loctite is still unset, you know, when it's a liquid on the threads. And then 10 minutes later, when all the Loctite's set, all the bolts are tight. You don't want to have bolts that are loose with Loctite setting up on them 15 minutes later and you ain't got them tight. So this needs to go really smooth on the reassembly. I think the key to that, like I said before, is going to be going to that bolt that's really hard to access and putting that one in first. So, you know, that's going to be a big deal. And then once it's started in, I'll want to start all the bolts in with Loctite on the threads and then go around tightening, and then just keep going around tightening, and hopefully get all of these bolts, which is a total of 6, 7, 8, 9, 11 bolts. I want to get 11 bolts tight, you know, in less than 10 minutes. And that's not going to be easy. And I may not get it in 10 minutes, but I'm going to do it as fast as I can. You know, if the Loctite is setting up a little bit, at the very last, it's not going to prevent me from tightening the bolt. But for the Loctite to work the best, we want to get it as fast as possible so it is as liquid as possible during the tightening, and then it can set up when they are tight. So let's go for it. Put her together. Hey y'all, we're coming to you from the break room here at NBS Weld, and I want to show you the t-shirts we got. The NBS Welding t-shirts got NBS Welding on the front, American flag on the sleeve, great big NBS Welding here on the back. Helps the channel if you buy a t-shirt. If you're interested in a t-shirt, send Tina an email request, nbswelding@aol.com. Thank you.